All right, Lizzie, let's talk about how you create the tangent line expression. The tangent line expression, you need three pieces of information. You need your derivative evaluated at your point C, x minus c, and then the original function evaluated at c. Now, in our case, c is 0. First thing we need to do is find the derivative. And right now, all we know how to use is the limit definition. So what I did is I put in x plus h. Well, first thing I did was FOIL out x minus 3 quantity squared. It's a little easier to substitute x plus h in if you've got the 3 terms instead of putting it in there and then squaring it. Chances of a math error are pretty big. So when you FOIL out x minus 3 quantity squared, you get x squared minus 6x plus 9. When I substitute x plus h in for every x, this is what the expression looks like. When I go ahead and simplify what I have in the numerator, my first check is good. My original function, x squared minus 6x minus 9, cancels with my x squared minus 6x plus 9. Everything will cancel out, so I'm left only with terms that have h. When you factor out an h and let the limit go to 0, you end up with 2x minus 6 as your derivative of your original function. We need the value of the derivative at 0, so the value of derivative at 0, when I substitute 0 in there, I get negative 6. So to create my tangent line expression, some use an L of x. I just wrote the word tangent line, just so you know that's what I found. My derivative evaluated at c was negative 6. Then the x minus c, so I just put x minus 0, plus my function evaluated at 0. So when I put 0 into my original function up here, I get the value of 9. Now, most times you can just leave it like this. You don't have to simplify it, but since it was minus 0, it was pretty easy to simplify. So the tangent line expression that you needed to find for this question was negative 6x plus 9. Hope that helps. Thanks. Bye.